Hey, everybody. I hope you're having a great day and wherever you may be. And we have a very exciting person with us today to talk about a very exciting product. So I'd like to introduce you if you haven't met this person yet. He's a fantastic developer. He's a DSP engineer as well, and he goes by the name of Jatin Chowdhury. How's it going, Jatin?
Yeah, thanks for having me on.
And Jatin has been nice enough to share his time to talk about a new open source project, which I think is very exciting because there are so many people that are looking to learn more about DSP and how these projects get put together, what the architecture of a big project like this looks like. And we will talk a little bit more about that in just a moment. Just wanted to remind you before we start that if you're not part of the audio programmer community, what are you waiting for? It's Jatin's in there and loads of other people are in there. We have about 7,500 developers from around the world, all different experience levels, from people who are actively working at some of the best and biggest music tech companies in the world, to people who are just getting started out, even students who are in high school. And we do our best to be as inclusive as possible. So no matter where you are or your background, your experience level, you're welcome. And you can join us on theaudioprogrammer.com/community. And you just fill out your information and just hit the button and you join our Discord community. And it's a great place where people help each other out, talk about things that are happening in the music tech industry scene and more. So come join us. I'll put the link in the description below. So Jatin, how are things?
Pretty good. Yeah, I'm happy to be here today.
Thank you very much. And what I'd like to do is maybe we could start out just talking a little bit about your background. So how did you get into this career field? What interested you in music tech and in audio and all of those good things? So I will pass the mic over to you to take it away.
Yeah. There's kind of a few layers to it, I guess. So I've been playing music for pretty much my whole life, and then sort of around the end of high school, getting into college, I had started messing around with music software with Ableton Live and Logic and things like that. Um, and then when I was in college, I started studying electrical engineering, and maybe after like I don't know, a semester or two, I had realized that all of my classes, I would learn these like electronic ideas or some computer programming, and somewhere in my brain I would go, hey, I wonder if we could do something musical with this. And so I would just come up with these hacky projects, and then eventually I was Googling around like, oh, I use all these plugins when I'm making music. Like, I wonder how they're made. And so I found that it was all C++ code, or mostly C++ code. And then my brother showed me the Juice library. And so I started learning that. And then just gradually I started making some plugins, or trying to make plugins in my free time. Uh, and that was sort of how it all started, I guess. I've just continued learning from there.
Wow. So your brother is an audio developer as well, or he knows about audio software development?
Yeah, he's more of a general software developer, I guess. He studied computer science in college, and so he knows Java, Python, C++, lots of different programming languages. Um, he's not really an audio developer, but he knows a little bit about the field. And now he's actually doing biomedical engineering and is really talented at that as well. So
That's awesome. So it sounds like your electrical engineering background was a great contributor towards the direction that you started to go in audio development. Is that right?
yeah, definitely. I think I've always had sort of a fascination with electronic circuits and kind of how they work and the different components and things like that. I've built a couple of just like, little project analog effects and synthesizer bits and things like that. Nothing that's, good enough to use regularly, but fun just for, playing around with for a little while. And yeah, I think that side of things is always really fascinating to me. And that's sort of where a lot of my uh, I don't know, enjoyment of music technology stems from, I think.
Do you think that audio developers need that sort of DSP background? Do they need to be putting circuits together and doing that, or what are your thoughts on that?
Oh, I mean, it depends on what you want to do, really. Like, I think if you know, if you want to be doing like analog modeling and things like that, then yeah, having a background in circuits and a little bit of circuit theory knowledge is definitely a good place to start. If you're more interested in just like purely digital signal processing, then understanding circuits may or may not be that useful for you. Or if you just want to think about things, from a more overall level, like, oh, I don't want to know how a Chebyshev filter works. I just want to use it. Then maybe you don't need to know any of that stuff, and you can just use these tools that other folks write the code for, and then you can integrate them into your own projects however you like. So yeah, I think it kind of depends on how deep you want to go into the different sides of things.
Mm-hmm. And you said a key phrase there, analog modeling. And for people who don't understand or may not have heard that term, what is that exactly?
Yeah, so the basic idea, and this is also called virtual analog modeling or things like that. If you're reading papers, you might see the phrase VA come up. And basically, at least the way that I've heard it used, it's like you have some physical circuit, usually from a guitar pedal or some rack gear or something like that has a circuit in it. And then you're making a model of that circuit in a digital system. So you're writing some code that is attempting to emulate what the circuit is doing. And there's a bunch of different ways that you can go about trying to do that.
Mm-hmm. Yeah, can you talk a little bit about some of those different ways? So you have like white box, black box, gray box.
Yeah.
What do those terms mean?
Well,
I'm testing you right now.
yeah, I mean, there's a little bit of I don't know. I've heard different definitions thrown around for all of those terms as well. But the way that I usually think about it is, if you're making a white box model, you're attempting to understand sort of the physical mechanisms behind how the circuit works. So you're saying, okay, I know that a resistor does this and has these physical properties, and a capacitor does this and has these physical properties. And so you sort of build up your circuit model from those very basic physical properties of the underlying circuit elements. With a black box model, you're more thinking, okay, I don't really care about what's going on inside the circuit from a physical perspective, or maybe I don't even need to know like what components are in the circuit at all. All I care about is if I put in some sound, what sound do I get out? And so usually the way that you approach it is more from making measurements. You say, okay, I put in this signal and I get this signal out. So all I need to do now is create some digital system that when I put in the same signal, I get the same signal out. And so kind of the poster child example for a black box model is an impulse response, where like instead of, if you're thinking about reverb, like a physical model or a white box model would be trying to figure out all of the equations behind how the sound travels around the room and things like that. Whereas an impulse response would be a black box model where you say, okay, if I put in this sound, then I get this other sound back out.
Yeah, and so to give people a more expanded view of what that could mean, if you had a guitar pedal that had one dial on it, maybe you could take measurements of a signal, something like a white noise blast, right, or a sine tone or sine sweep at 10 different points. At you test it when the dial is turned to 0, when it's turned to 1, turned to 2.
Exactly. Yeah, I can actually show an example of that.
I'd love to see an example.
So
yeah. Yeah. So just while he's pulling that up, another thing is discussing the complexity of what that can look like, because if you have one dial and you're taking measurements of that dial, then you have 10 possibilities, right? But if you have two dials,
oh yeah.
so now you're talking about 10 to the power of 2 possibilities of where that could be. And then it just exponentially goes up from there in terms of, and so these can be quite intensive in terms of CPU load. Am I
yeah.
right?
Well, CPU and memory, like if you're thinking about the impulse response example, maybe you have 10 impulse responses for each knob setting. And so then maybe you need 100 impulse responses. And if each impulse response is, I don't know, like a megabyte or something, then as you get to 10 or 11 knobs, maybe you need a lot of impulse responses.
Yeah.
Yeah, it can be pretty intensive, and it can also be just like a little bit annoying to have to deal with. But yeah, I think that's sort of one of the, if you're thinking about like the advantages and disadvantages of the different modeling types, I think that with black box modeling, the fact that it can be difficult to incorporate sort of control parameters is one of the disadvantages.
Hmm.
And white box modeling has its own disadvantages, like, you need to do a lot of math to get anywhere.
Hmm.
uh, so yeah, there's different trade-offs there, but yeah, I can actually show this here.
Yeah.
Can you all see this?
Yep.
Cool. Yeah. So this is in the plugin I'll be showing in a minute. This is the GuitarML module, which if anyone here follows him, Keith, the developer from GuitarML, makes these fantastic machine learning models of guitar pedals and guitar amplifiers and other. I think he's only done guitar devices so far, but I'm sure maybe he'll expand to other things eventually. But yeah, so I believe for the TS9 model, the Tube Screamer, I forget, he had an earlier model that did not have a control parameter included. And then I think this is using the newer model that does have the control parameter. But basically what he did is he took his Tube Screamer, made some measurements, trained a neural network to recreate the measurements. And so it's like a really nice example of black box modeling for a distortion pedal or a highly nonlinear circuit. So yeah, that's a black box model right there.
Yeah, there you go. That's awesome. And while we're on it, just if you want to see what that looks like, is all of that code available for the Guitar ML?
Yeah, I believe all of his code is up on GitHub. We can toss a link in there somewhere.
Yeah, we'll put a link in the description. Big shout out to Keith. I've been talking with him recently, actually. So
yeah, he does some great work.
yeah, that's awesome. So if you want to see how these types of devices are built, it's a really exciting time in music tech right now, because it feels like there's been an explosion of open source projects that show you how to build just about anything. There are even open source DAWs out there that are pretty phenomenal and very feature filled. So yeah, it's a good time. Great. So Jatin, can you tell me a little bit about some of the first projects that you started out with? So what were some of the first things that you did when you were first starting out in plugin development?
Yeah, so the first thing that I wanted to do was make a compressor, because at the time I was using the Ableton stock compressor for everything, and it was okay, but I wanted something with a little bit more sort of like more of like a pumping characteristic to, be a little more exciting, a little more aggressive for some of the mixes I was working on and stuff like that. And so I worked on that for, I don't know, several years and never really got that far with it. But in the process, I ended up making a really crappy sounding compressor that I just started using as its own effect. So that was a fun process. And then maybe, I don't know, a little while later, I started on a distortion plugin. And neither of those really, I don't think I did an official release ever for either of those plugins. But that was sort of the original stuff that I was working on.
Nice. And you have several other open source projects that you've actually released. Can you tell us a little bit about those before we dive into this one?
Definitely, yeah. So the first plugin that I ever did like a real release for, and I actually hadn't planned to, was a tape emulation plugin that I had originally just done as a research project. Originally it was for a class, and then I ended up submitting it to the DAFX conference as well for that year. And mainly what I was trying to do was just put this plugin on GitHub as like an example of the research paper that I'd written. And then a couple people on the KVR forum found it, and a friend of mine emailed me and was like, "Hey, all these people on KVR are talking about your plugin." And so I actually it was Chris Roberts who was on the audio programmer meetup a couple weeks ago. He emailed me and was like, "Hey, you should check this out." And so I decided, okay, well, if people are interested, then I'll try to make it a little better, do a little release for it, just some little things like that. And then after that, I did a few more. I did a phaser plugin and a guitar pedal, the Clon Centaur pedal, and then yeah, a couple others that are all on my website now.
Yep, there's the kick plugin as well, Chow Kick.
Yep.
Yeah. Yeah, so if you're trying to find out a little bit more about how these plugins are built, I would encourage you to go to Jatin's GitHub page, and you can download these. These are open source, and you can take a look at the source code. You can try to fiddle around with them, rebuild them from scratch. Yeah, so it's pretty liberally licensed as well. Am I right in saying that?
Yeah, I think all of them are either GPL license or BSD license. So yeah, you should be able to use them for open source stuff, and some of them you can even use for non-open source stuff if you like. But yeah, it's all up there on GitHub to take a look at.
Fantastic. But we're here to talk about this project, which came out very recently, called BYOD, which stands for?
It stands for Build Your Own Distortion. Although someone recently told me that it also stands for Bring Your Own Device, which I had not heard until I don't know, like a week ago.
That sounds very music techy. That's great. And can you tell me a little bit about the concept of the plugin?
Yeah, so basically, after I had released my first like guitar pedal plugin, I had a bunch of emails and messages and people being like, "Hey, here's my favorite pedal. Can you model it?" And especially for pedals that hadn't been modeled very frequently in other plugins and things like that. And a lot of them, I was looking at the circuits and they were really interesting, and I was like, "Yeah, it'd be great to do it." But as I started thinking more about it, I was like, "Okay, well, making a plugin is a lot of work, and like especially as you sort of if I were to do like 10 guitar pedal plugins, that would be a lot of sort of maintenance work on my end, which can be, I don't know, a little bit annoying and just a little bit time consuming and things like that." And so it's like, well, I don't want to release a bunch of little plugins. But the thing that I found more interesting was that as I was looking at these circuits and starting to understand them more, I was noticing that a lot of them had very similar little parts of their circuits. Like there was a configuration with the op amp where you have a feedback loop and there's some diodes in the feedback loop, and that's kind of the tube screamer circuit. Or there's like a diode clipper circuit where you have like some signal and then a diode going to ground, and maybe you've got 3 or 4 diodes or something like that. It just kind of depends on the circuit. Or there were some various tone circuits that seem to be coming up quite commonly as well. And so eventually I was thinking about it and I was like, well, what I would find personally more interesting, both as a DSP engineer and also as a musician, would be, well, what if instead of just modeling a tube screamer pedal and modeling some other pedal, what if I model just the distortion stage from the tube screamer and then just the tone stage from the tube screamer, and do that with a bunch of different pedals, and then you can kind of mix and match. Like, okay, I want to know what the drive stage from the Clon Centaur sounds with the tone stage from the Big Muff or something like that. And so that was kind of the original concept.
Wow, sounds pretty awesome. How long did it take you to write this?
Oh man, so I started working on it. I guess I probably had the idea maybe in the spring of 2021, so maybe like April or so, and then I think I started writing the code maybe in like June or July. So I think it ended up being like 9 months of pretty steady work.
Mm-hmm. And what's really interesting is that it's not just a drop-down menu. A lot of people would have probably done just a drop-down menu where you would just select the tone, select something else, and there you are. But you've actually elected to do it more of a node-based environment. Can you describe that thought process a little bit?
Yeah, so I had I shouldn't have pulled up a picture of this, but much earlier in the process, I had it set up so that it was sort of like a horizontal layout, and you pick, however many little pedals you want in series, kind of like you would on a, traditional pedal board where you have, this pedal and then that pedal and then that pedal, or I learned recently that most pedal boards, the signal flow goes the other way. I always think left to right because I don't know, I learned to read that way, but I learned recently that most guitarists actually have it go the other way in their rig. Um, but yeah, it was just kind of a horizontal like series layout. And then a friend of mine, I don't remember his real name, but his GitHub name is Evil Dragon. Uh, I was chatting with him about it, and this was very early on, and he was like, "Okay, so now what if I want to do a parallel, like some parallel signal routing or like stereo splitting or something like that?" And I mean, you know, those are things that a lot of guitarists do. Maybe not all of them, just because it's a little bit tricky to do with pedals sometimes. But I was like, yeah, that'd be really cool, but I need to figure out how to do it. And then, you know, after a while, I kind of like that part took probably the longest, was just figuring out how to go from like a straight up like series signal flow to sort of an anything signal flow. And it's not really anything, like even now you can't do feedback or things like that. But being able to do like a flexible signal flow where you can do parallel routing and then kind of merging things back together. Yeah, that took a little while to figure out.
Yeah, I'm very curious when we dig into the code a little bit later, exactly how you look to solve that problem.
Yeah.
So maybe we could start by just you giving an overview of how it works, maybe a demonstration.
Sure. Yeah. So I guess the basic thing that you see, this is sort of the default mode of the plugin where you have some input and some output. And then your input, you can kind of choose where it comes from. So with my sound card, I have my guitar going into the right channel, and then I need a little extra gain on the input. And then you sort of got these global dry wet and oversampling controls and things like that. And then on the sort of the darker gray background here, this is like your pedal board. And so you can right click, or you can use the plus menu here to sort of add a pedal. So you can choose what type of pedal you want. Maybe the most important one is you got your tuner, so you can tune your guitar. But then beyond that, you've got all of these distortion pedals. So for example, where is it here? Here's the distortion circuit from it was modeled after the Dallas Range Master. I hadn't thought of this initially, but someone had mentioned that, oh, you probably shouldn't use like trademarked like product names or things like that. So I had to go back and change a bunch of names, but this is modeled after the Range Master pedal. And then maybe you want like the tone stage from the Big Muff or whatever. And then you can just route that into your output. And now here's your, you know, your pedal signal flow. Or maybe you want to do like a parallel routing or something. So you could have like a tremolo and then I don't know, some amp impulse response or whatever. And then to do like a merging, you've kind of got a few ways that you can do that. So you can do like a stereo merge. So one channel goes left and one channel goes right. Or you can just do like a plain mixer and just put, you know, your mixer channel and send that to the output. And yeah, so that's kind of how you can build up you can use it to kind of build a pedal, or you can use it to sort of build a pedal board, depending on how you want to think about it.
That's really awesome, and really awesome that you have those utilities there as well. It's pretty
yeah. Yeah, I don't know, after maybe like a month or two of just like playing around with it myself, I was like, you know what, I really need an oscilloscope just so I can sort of see the level and just little things like that, where it's like, okay, I have all these great like these things that sound really cool, but I just need some ways of putting them together that work a little bit more nicely.
Yeah, really awesome. So one question I wanted to ask you is, this could probably be a commercial product. So can you talk a little bit about your motivation for open sourcing the project and putting the code out there for other people to check out, and the motivation behind that?
Yeah, so when I was originally thinking of the idea, I was like, well, maybe it could be a commercial product, maybe not. I hadn't really decided. And then as I was starting to work on it, I started realizing that there were a lot of a lot of things that I wanted to use that were code that I hadn't written. And I still wanted to use them, but I needed to sort of figure out a way to, use these other people's code, to credit them for their code, to make them feel as though, I wasn't just sort of taking their code and using it in my thing without any recognition or whatever. And so what I ended up doing was I decided, okay, I'll make it open source. So it's GPL licensed. So if these people want, they can let me use their code or their signal processing derivations or whatever under this license. And then there's an iOS version too. And so the GPL license doesn't work with the iOS app store. And so I sort of put in a caveat where it's like, okay, if you want to let me use your code, but you don't want it to be used in the iOS version, just let me know and I can sort of, finagle things so that specific block doesn't exist in the iOS build. But that sort of led to some really nice things. So for example, we have a model of the MXR Distortion Plus, and this was originally done by my friend Sam. He had written the original code and done the original derivation in his master's thesis. And yeah, I'm really glad that we were able to use it in BYOD. And if it hadn't been open source, I wouldn't really have felt comfortable asking him to sort of just give me that code for nothing. So yeah, I'm glad that kind of because it's an open source project, I'm able to pull in code from various other places and various other people, and it can be a bit more of a collaborative thing.
Amazing. Great. Where would you like to go from here? Would you like to talk a little bit about the code, or are there other features you'd like to discuss?
Yeah, let's talk about the code.
Okay, cool. So I guess one of the first questions is what was the most enjoyable part for you? What was the most?
I think for me, I have sort of a very short attention span, and so I have trouble with ideas that take a really long time and are sort of very long form things to work on. And so what I enjoyed most was just sort of the fact that I could just say, okay, tonight I'm going to work on this pedal, and then I could just say, okay, today I want to work on like a wah-wah filter or like a what do you call it? Envelope filter. That's the guitar and bass player's name for it. So okay, today I'm going to work on an envelope filter, and so I could just work on that for like a day or two, and at the end of the day or two, it would be mostly done, and I'd say, okay, that's part of BYOD now. And so just having these very little pieces that would be okay. Today I can do that, and that was all. And I really enjoyed sort of that. It's a modular project, both in the way that you can use it and in the way that I worked on it. And I think I found that very enjoyable.
And did you use the Juice, was it audio processor graph? Is that what you used to actually be able to modularize the system and be able to connect nodes, change them around?
Yeah, I knew that question was coming. So when I decided to make the switch from sort of the plain serial audio graph to sort of a modular one, I had looked into a few different sort of solutions. I looked into the Traction engine, and I looked into the Juice audio processor graph. And after a while, I was like, okay, these are both very powerful tools, and there were a few other things on GitHub that I had looked at as well, but none of them were really sort of what I wanted. I think that they're more, at least from what I understood, they're more based, they're more designed to be used in a DAW where you've got tracks and different things like that that are being routed in a certain way, whereas this is, I guess, a little bit more freeform.
Mm-hmm.
So what I ended up doing was kind of implementing my own, I called it a processor chain. Here I can, processors. Yeah, I can show you all here. Cool. Yeah. So basically, I have this process audio method, and I need a little spin lock here to make sure that if the audio graph is changing, if I'm adding or removing a processor, then I can sort of skip processing while the graph is changing around. But then from there, the main thing that I do is I call this run processor method, and that just takes whatever signal is coming from the input processor. So that's just here.
And while you're doing that, yeah, so some people may say you should never lock in your process in your audio processing block, but with this, there's a specific use case, isn't there? So so sometimes it's a situation where you have to know the rules in order to break them when needed, right?
Yeah, so this was something that I actually got from Timur Jumler's article about using locks in real-time code. And the nice thing about the juice spin lock implementation, I know there's some sort of pros and cons to it, but the thing that I like about it is that if you want to use it in the audio thread, it's like the tri-lock version of the lock is just checking an atomic. So it's not really like locking in the audio thread in the sense that there's like, you'll never run into a situation where the audio thread has to wait until some other thread is done with whatever it's doing. If you're trying to grab the lock and you fail, it's a very quick failure path. And it's, I don't know, I guess it's a deterministic failure path. I guess the problem with spin locks is that sort of when trying to access it from your other thread, you can run into a situation where you're just waiting and waiting and waiting. So that can be a bit of a problem too. But yeah, I would definitely suggest reading Timur's article where he sort of gets into the nuts and bolts of that situation. But yeah, so getting back to the processor chain, so you've got this input processor here. And so when you call run processor, it will start from the input processor and then continue processing audio until it either reaches the output processor or until there's no next processor. And the way that works is through this sort of recursive situation here. So basically, it's kind of this, I don't know, this is probably the most difficult method that I had to write in the whole plugin. But basically you check, okay, am I at my output processor? If I'm at my output processor, then we're done. If maybe this is like the oscilloscope or something where there are no outputs, so then we're done. Maybe there is nothing connected to this processor, so there's nothing coming after it, so then we're done. And if you're not in any of those situations, then you need to sort of get into the recursive side of things. So this is it's a little bit tricky because there's some processors with multiple outputs. So for example, the stereo splitter, you've got multiple outputs, and there are some processors with multiple inputs, like the mixer that you saw, or the stereo merger, which is kind of the sister processor, the corresponding processor for the splitter. So yeah, I'd have to review this logic a little bit, but basically, whenever you get to a processor with more than one output, you kind of have to deal with each output and say, okay, let me get to the next one in the chain here. And then when you get to this one, you have to wait until sort of all the inputs are there. And then if not all the inputs are there, then you sort of wait and keep processing other things along the way. And then once all of the inputs are there, then you can continue.
Wow.
Yeah, this is, I probably need to document this method a little bit better because it's, yeah, it's a bit of a beast, but that's my audio graph for this plugin. And I should mention that it's not really like a fully featured audio graph. There's a lot of things that aren't supported. Like I mentioned earlier, there's no way to do like feedback from one module into itself, or into itself through a chain. And maybe the biggest thing is there's no latency compensation or anything like that. So kind of the one like rule I have for all of the modules is that none of them can introduce latency, because otherwise this whole sort of graph situation gets a little bit out of hand. And I think that's fine too, since it's meant to be like a guitar pedal type plugin. Like I want people to be able to use it in a live recording situation or even a live performance situation if they want.
Mhm. And what about the UI? Were there any particular challenges in regards to that?
Yeah, there were a few. So one was kind of a simple one was just being able to kind of resize things. So I wanted to be able to resize this whole like processor without it becoming like, I don't know, unwieldy, or without the text getting too small or too big, or the knobs getting too small or too big. So I had to spend a good bit of time making sure that everything scaled pretty well. I guess another thing I should mention is that in the code, there's very little sort of UI customization done for each module. So each module has sort of a generic editor, and then you pick some colors and things like that. And then obviously, like for the tuner, you need this custom component in the middle there. But for the most part, it's just I define my parameters, I define my colors, and that's all. And so I had to try to set up a generic editor that would work for any number of parameters. So for example, like there's an EQ, and so I had to set it up to have these linear sliders for the EQ. And so yeah, there's a lot of sort of like little things that I had to get right. And I'm sure it can be improved as well. Like you can see the text on the EQ is pretty small, although it gets better if we make it a reasonable size.
Mhm. And what type of UI approach did you elect to do for it? Did you use Flexbox, or did you use a grid, or how did you handle that, or did you use just static, like comparative measurements? What did you do there?
Yeah, so for the processors, it was basically just like a percentage based approach, where it's like, okay, your knob height will be this percentage of your total height, and then there's a little bit of padding here and there, and a few sort of little things like that maybe are a little bit more static. For the plugin as a whole, I actually use plugin GUI Magic, although I'm used to using it for a lot of my plugins, but for this one, it turned out to be like not particularly useful. I mean, you get the bottom bar and the top bar, and that's basically all the plugin GUI Magic is doing for me. So I'm not sure that it's really worth it, but I'm just used to using it at this point, so it's okay.
A big shout out to Daniel, the creator of plugin GUI Magic.
Yeah, it's really nice.
Yeah, we'll put the link to that below in the description as well. So really awesome for building plugin UIs. So awesome. Big shout out to Daniel.
Yeah.
Yes. Wow. So, and what about the connection, the node connection? How did you handle that? Did you look at the audio, the Juice plugin host for that, or did you read about that? Yeah.
Yeah, when I was looking at that, I don't know, I thought about a few different things. I looked at the VCV rack implementation, but they have more of like a 3D look for the whole like the whole UI, so it didn't really fit with like what I had going on already. So the main thing was just sort of getting this like cable view. So in like Juice terminology, the cable view is like an overlay over the entire like pedal board here. And so whenever you click on anything, like you're clicking on the cable view. And so what I had to do is make these port elements. So whenever I click on a port, it passes the information up to the cable view, and then the cable view actually draws the cable. And then, yeah, it was a little bit tricky sort of setting up these fields so that when you get close to the port, it highlights the port and things like that. So yeah, the cable view is just sort of drawing everything on top of everything else. And then for getting the like the, I don't know what to call it exactly, like the curviness in the cables, I had borrowed, there was some other GPL code that I stumbled across somewhere that had like a nice spline. And I tried a few other things as well. I think Juice has like a built-in spline method or something, but I didn't like how it looked quite as much. And so I tried out a few algorithms, but for whatever reason, that one I thought looked really good. So I stuck with it. And so basically the way it works is you have like one spline point, which is the center of the dot there. And then you have another spline point that's like a few pixels out. So that's how you get sort of this little like, but like it's hard to describe, but without those points, it's a little bit like, it doesn't feel quite like a real cable because the line like goes off in that direction too quickly. So I had to add a control point like a few pixels out from each port, and that made it sort of smooth pretty nicely.
Nice. That's really awesome.
Yeah. I will mention I'm not really great with the sort of the UI side of things as far as like knowing what will look good. So a lot of this was I'm part of the Surge Synthesizer Discord, and so when I was working on the cable specifically, I would like work on it a little bit and then like post a screenshot to there, and people would be like, "Oh, you should make it look a little more like this or a little more like that." And so actually the fading colors and like the circles around the dots on each port, like those were all ideas that folks there came up with and shared with me, which was really fantastic as well. So yeah, big shout out to everyone over there.
Yeah, big shout out to the team that are working on the Surge synthesizer. Bacon Paul, you're contributing there, and many others. So if you're looking for a fully fledged synthesizer that's open source, and you can see the source code for everything, that's really well put together, check it out.
Yeah, and they're looking for contributors as well, so definitely hop in if you're interested.
Yeah, that brings a great segue into where you'd like to go in the future with this, and contributions and things of that nature. So what are your thoughts around that?
Yeah, so it's definitely open to anyone to contribute. As I mentioned, it's GPL code, and then you can do the iOS thing if you want, or you can make it so your code is not in the iOS version if you prefer. Yeah, I have sort of a list of a bunch of other like pedals that I would like to add. I have one list on my own notepad, and then I have a bunch in the GitHub issues as well. So if you're interested in trying to model one of those, then that'd be great. If you've already got like a pedal model lying around that you'd like to contribute, that's obviously quite welcome as well. So yeah, whatever kind of contributions folks want to make, or on the UI side, I'm sure there's ways that this could look a little better, or be a little bit easier to use. Personally, I'm not a huge fan of cables, honestly. I spend a lot of time trying to get these to look right, but I never find it gratifying to mess with cables on a screen, especially since I find it a lot of fun in real life to be able to, plug in cables and things like that. But on a screen, it's not as fun. So yeah, if anyone has ideas for sort of how the interaction or the design could be improved, that's absolutely welcome as well.
I like the gradient, how you've done the gradient between the color of the input module versus where it's plugging into.
Oh, thanks.
That's really cool.
Yeah, that was an idea from someone on the Surge team as well. I forget who it was, but yeah, that was a really good idea.
Yeah, that's really awesome. So yes, Jatin is looking for more contributors. So if you're looking to contribute to a really cool open source project, we hope that you consider contributing to BYOD. It's a great way to get to add to your portfolio and show people what you've been up to, what you're capable of as a developer. If you're looking for new opportunities, I think it's one of the best ways probably to show people what you're up to and your capabilities and your skill level as a developer. Great. Is there anything else that we should discuss?
Yeah, I think that's all I've got at the moment. Actually, I had one idea that I was thinking of adding, which I haven't gotten around to, but maybe someone will have an idea for how to do this. What I had wanted to do is have like a power supply option. So I'd heard some guitarists talking about how like their guitar gear sounds a little different in the US versus the UK versus wherever other countries they might be playing in, because the power supplies are a little bit different, or the like the power grid, the power that you get from the power grid is a little bit different. So I wanted to have like a drop down menu down here where you can choose which country you're in. And that gives you a slightly different sound, but I haven't worked that out yet. So if someone has an idea for how that can be done, I think that'd be really
so
cool.
awesome. I love that. Fantastic. Yeah, great. How if people wanted to license some of this code that you've actually written, how would they do that? How would they get in touch with you?
Yeah, the easiest way is to just email me. You can email me through chowdsp@gmail.com. But it's also worth taking a look. In each module, there's a little info page where it can tell you like which people or person worked on it. So if there's a specific module or something like that that you'd like to license the code for, definitely take a look at the info page, and that should give you an idea of who to contact.
Awesome. Yeah, great. Thanks for walking us through this. Really cool.
Absolutely.
Yeah, and as Jatin said, it's completely open source, so you can look at the code for any of this stuff. So if you're trying to figure out how in a UI setting you can route cables, cable points to one another, you can get ideas from that. How DSP is written, you have loads of different things. How an environment, a Max MSP like environment where you can basically create your own signal graph is created. A lot of really useful knowledge. So thank you very much for walking us through that, Jatin.
Yeah, no problem.
Great.
Always fun talking about some code.
Awesome. And as I was saying before, if you, all of the links for the project, getting in touch with Jatin, and also stuff like plugging GUI Magic and the other relevant links will be in the description below the video. And for now, we will leave you to hopefully go back to your computer, open up your IDE, and start making some really cool, interesting audio plugin or audio software development projects. And we hope that this has been inspiring for you. It's definitely been inspiring for me. So I can't wait to check this out some more.
Awesome. Thanks. Yeah, hopefully people will get in touch. And yeah, I'm hoping that people are excited to make cool things.
Yeah. And if you're looking to catch up with Jatin, another place where you can probably catch up with them would be our audio programmer community on Discord. So once again, if you wanted to join there, that would be, you can register at theaudioprogrammer.com/community. And also the Surge Discord. So there is Bacon Paul, who is the head developer of the Surge synthesizer. And at some point, I need to get Paul on here to talk a little bit about Surge and the great work that y'all are doing with that as well.
Absolutely. Yeah, we're moving towards Surge XT 1.1, which is going to be very exciting. They added undo redo pretty recently, so that's a lot of fun.
That's a very common question that many people ask about is undo or redo.
Yeah.
So great. Thank you very much. I will end this recording now, and we will hope to see you again soon.
Awesome. Thank you.